On the morning of July 10th, 1943, a young British sergeant named Thomas Grieve waded ashore on the southwestern coast of Sicily. He had survived the landings. He had survived the surf. He had survived the fire from the Italian coastal batteries on the bluffs above the beach. What he had not prepared for, what no briefing officer had thought to mention, was the bathroom. The farmhouse his platoon occupied that first night had a toilet. Not a hole in the ground, not a bucket behind a curtain. A toilet. White porcelain, bolted to a tiled floor, connected to a pipe that disappeared into the wall. Grieve later wrote in his diary that several of his men stood around it for several minutes before anyone would use it. They had seen toilets before, obviously. What they had not seen was one that worked. When Private Alderton reached down and pushed the flush handle, water fell cleanly into the bowl. The bowl emptied, and clean water refilled it. Alderton turned to his sergeant with an expression Grieve described as awe. "Who put this here?" he asked. Nobody had put it there. It had been installed, inspected, tested, and certified, the same way every other fixture in every other building connected to the Palermo municipal water system had been installed, inspected, tested, and certified. That was the point. Nobody had put it there. A system had. 2 years later, when American GIs pushed into Germany itself, they encountered something unexpected in the ruins. German plumbing that did not work. Not because it had been bombed, though much of it had been. Not because the pipes had frozen, though that winter was savage. It did not work because it had never, in any consistent sense, worked. A German bathroom in 1945 was a testament to the skill of the man who had built it, and to no one else. If that man had measured wrong, the fixture leaked. If that man had died in Stalingrad, his replacement measured differently, and the fixture leaked differently. The Americans washed their faces in working sinks. The Germans heated water in pots. This is the story of why. The invisible infrastructure. To understand what shocked the Europeans, you have to understand what American soldiers carried with them that they could not see. It was not in their packs. It was not in their field manuals. It was not in the machinery that the Liberty ships hauled across the Atlantic in such quantities that German U-boat commanders stopped believing their own tonnage reports. It was in their expectations. An American soldier of 1943 expected water to come out of a tap when he turned it. He expected a toilet to flush when he pushed the handle. He expected a shower to produce warm water at a predictable pressure. These were not luxuries to him. They were facts about how the world worked. That expectation had been manufactured in him, the same way a rifle was manufactured, by a system of tolerances, standards, and inspections that had been developing in the United States for the better part of a century. By the time he was born, American municipal water systems were already the most extensive and reliable in the world. By the time he was old enough to notice plumbing at all, he had already absorbed the lesson that infrastructure was not personal. It did not depend on knowing the right man. It did not require a tip or a favor or a cousin in the trades. You turned the tap and water came out. The sophistication of the system was precisely that it had made itself invisible. The European soldier had learned a different lesson. In France, in Britain, in Germany, in Italy, plumbing was a matter of class and geography and luck. In Paris or London or Berlin, the wealthy had reliable water. Everyone else had something approximating it, variable by season, by district, by the competence of whoever had last touched the pipes. In rural Europe, the question was often not whether the water pressure was adequate, but whether there was piped water at all. When European soldiers encountered American infrastructure, military or civilian, They were not simply impressed by the engineering. They were disoriented by its uniformity. The same tap worked the same way in California and Louisiana and New York. That was not an accident. That was the American system, applied to water. The riddance of the craftsman's monopoly. In 1848, a Philadelphia plumber named John Guest filed a complaint with the city's building committee. The substance of the complaint was simple and furious. Guest argued that the city's new water system, recently expanded under the direction of Frederick Graff's successor at the Fairmount Waterworks, was being undermined by contractors who hired unskilled labor and used standardized brass fittings manufactured in New England. Guest and the other master plumbers of Philadelphia had spent years, some of them decades, learning to pour and shape and fit lead pipe by hand. A lead joint made by a skilled man was a work of craftsmanship. It was also irreplaceable. Only that man, or someone trained to his standard, could repair or extend it. The new threaded brass fittings could be tightened by any reasonably intelligent laborer with a wrench. Guest understood what this meant. It meant the end of his monopoly. Guest lost his complaint, as was inevitable. The economics were too powerful. A brass fitting manufactured to a standard thread specification at a factory in Connecticut or Rhode Island cost a fraction of what a skilled plumber charged to pour a custom lead joint. More important, it fit. It fit every time. A factory thread cut to specification on a fitting from Hartford would mate with a factory thread cut to the same specification on a pipe from Providence. No fitting, no hand dressing, no adjusting. You assembled the joint, you tightened it, it held. That was the principle. It was the same principle John Hall had demonstrated at Harper's Ferry with rifle parts, the same principle that Henry Ford would later apply to automobiles, the same principle William Knutson would enforce across the American war economy 2 generations after Guest filed his complaint. The principle was standardization, and it transferred. By 1855, the American Society of Civil Engineers had begun work on what would eventually become national standards for pipe threads. By 1864, the Sellers thread standard, developed by William Sellers of Philadelphia, had become the de facto American standard for threaded fasteners. Europe had its own thread standards. Britain used Whitworth threads. Germany used metric threads. Each was internally consistent but mutually incompatible. A British pipe fitting would not mate with an American fitting. A German valve would not accept an American nipple. This was not a trivial engineering inconvenience. It was a statement about the boundaries of the system, and those boundaries were national. In America, the boundaries of the standardized system were the boundaries of the country. In Europe, they stopped at the border. The roaring pipes of the New World. The decades between the Civil War and the First World War transformed American cities faster than anything that had come before them. Between 1880 and 1910, Chicago grew from 500,000 people to 2 million. New York grew from under 2 million to nearly 5. These were not just population numbers, they were sanitation emergencies. Typhoid and cholera, the characteristic diseases of contaminated water, killed Americans by the tens of thousands every decade throughout the 19th century. The construction of reliable municipal water and sewer systems was not a luxury or a civic ornament. It was a matter of urban survival. The men who built those systems, the engineers of the Chicago Sanitary and Ship Canal, the planners of the New York Croton Aqueduct, the superintendents of the Philadelphia Water Department, worked under a constraint that European city engineers did not always face with the same urgency. They were building for scale. A European city of 100,000 people, built over centuries, had plumbing that had accreted organically, pipe by pipe, neighborhood by neighborhood, each section fitted to the last by the tradesmen who laid it. An American city of 100,000 in 1885 might have been a farming town of 10,000 in 1865. It had to build its infrastructure from nothing, fast, to accommodate people arriving faster than the pipes could be laid. Fast infrastructure at that scale required standardization. There was no other way. The contractor building the water mains on the north side of Chicago could not wait for a master plumber to hand fit each joint. He ordered pipe in standard diameters and fittings with standard threads from a catalog, had it railed in from a factory in Pittsburgh, and put laborers to work assembling it. The inspector who came behind him did not check the craftsmanship of individual joints. He checked the system. He tested the pressure. He measured the flow at the hydrants. The unit of quality was not the fitting. It was the network. That shift from valuing the individual craft object to valuing the system's performance was the deepest change American infrastructure made. It was also the change that Europe, for reasons cultural and historical and structural, was slowest to absorb. The Facharbeiter and the inspector. In Germany, in the years before the First World War, a plumber was not merely a man who laid pipe. He was a Facharbeiter, a skilled craftsman, certified by a guild examination that tested both his theoretical knowledge and his practical ability to work in lead, brass, and iron to tolerances measured by eye and hand. The German Facharbeiter took justified pride in his work. His joints did not leak. His fittings were smooth and true. When a German nobleman's estate had a problem with its water supply, the estate's plumber could diagnose it and repair it with a skill that had no American equivalent in individual terms. The German craftsman was better as an individual craftsman than almost any of his American counterparts. But the German craftsman was also irreplaceable in a way that the American system had deliberately engineered away. When the German craftsman's water system failed, you needed the German craftsman or someone trained exactly like him to fix it. The knowledge lived in the man, not in the system. The American system had done something that looked, from the outside, like de-skilling. It had taken the tacit knowledge of the master plumber and encoded it in the tolerances of manufactured parts and the specifications of standardized installation procedures. Any reasonably competent man with basic literacy could follow the specification and produce a correct installation. The knowledge no longer lived in a person. It lived in a document, a gauge, a thread standard. And a document could be reproduced. A gauge could be duplicated and shipped. A thread standard could be printed in a catalog and sent to every contractor in a city, a state, a nation. This was the answer to Thomas Greaves' question. Who put this here? Nobody in particular, which is to say, the system. The toilet in the Sicilian farmhouse worked because Italian municipal engineers, trained on German and French technical methods, but supplied increasingly with American standard fixtures manufactured to American tolerances, had connected it to a water system whose standards were clear enough that it functioned without requiring the specific knowledge of the specific man who had installed it. And the American supply chain, which had manufactured those fixtures, had been doing exactly that for 80 years. What the Army found. When the United States Army began planning for large-scale operations in Europe and the Pacific in 1942, one of the least glamorous and most consequential decisions its logistics planners made concerned field sanitation. The question was simple. How do you maintain acceptable sanitation conditions for hundreds of thousands of soldiers operating in environments where the local infrastructure ranges from inadequate to non-existent? The answer in the American system was to bring your own infrastructure and make sure all of it was interchangeable. The Army's field sanitation manuals of 1942 and 1943 specified standard fittings, standard hose connections, standard pressure ratings for water distribution equipment. The Lister bag, the standard Army water purification unit, connected to standard pumping equipment with standard fittings. A field engineer in Tunisia could attach the output hose of his purification unit to the input fitting of any distribution tank in his division without measuring, without modification, without improvisation. It dropped right in. The same was true of the shower units, the field laundry equipment, the hospital water supply systems. Every component was sized to a standard. Every connection was threaded to a standard. You could strip the plumbing out of a field hospital in France, crate it, ship it to the Philippines, and reinstall it without machining a single custom part. British military engineers, working alongside the Americans in North Africa, were simultaneously impressed and faintly embarrassed by this. British field sanitation equipment in 1942 was largely a matter of what you could locally acquire, modify, and improvise. The British Army had a long tradition of making do, of solving problems with ingenuity and local materials, of finding the right man for the right job. That tradition had produced genuine engineering brilliance in individual cases. It had also produced water supply systems that worked perfectly for the man who had built them and bewildered everyone who came after. When a British unit moved and a new unit took over their positions, the handover notes for the water system were often 4 pages long, explaining every improvised connection, every workaround, every fitting that had been slightly cross-threaded and needed to be turned just so. An American unit's handover notes on the same subject were often a single sentence. The system is standard. Refer to FM 21.10.
The German collapse. By the winter of 1944, the German army was conducting what its officers called mobile defense and what everyone else recognized as a fighting retreat. Across France, Belgium, and the Low Countries, German units fell back under Allied pressure, attempting to maintain cohesion and fighting power while abandoning position after position. The logistical challenge this created was immense, and it intersected with German industrial culture in a way that made it worse than it needed to be. German military field equipment, like German industrial equipment generally, was built to high standards of individual craftsmanship. A German field water purification pump was an excellent machine, well-made, precise, durable under normal conditions. It was also, like most German precision equipment, manufactured to tolerances that assumed the involvement of skilled maintenance personnel. When components wore out or were damaged, they were not simply swapped, they were fitted. A replacement bearing for a German pump motor arrived from the factory slightly oversized because the factory assumed that a trained mechanic would turn it to the exact dimension required for that particular pump. The bearing did not drop in, it was worked in by a man who knew what he was doing. In the fluid conditions of the winter of 1944, with German units moving constantly and their logistical chains stretched and frequently interdicted, that man was not always available. The mechanic who knew how to fit the bearing might be 300 kilometers to the east. The replacement part might arrive with no documentation except a part number. A German corporal with moderate mechanical aptitude trying to keep his unit's water supply running could not do what his American counterpart could do. His American counterpart opened the crate, read the instruction card that was printed in large type with clear diagrams, assembled the replacement component with the standard tools listed in his equipment table, and turned the tap. Water came out. The German corporal, without the right man and the right knowledge, had a crate of parts and no water. The pipe that won the war. No one wrote about. Historians of the Second World War have written extensively about the weapons that decided the conflict. The Sherman tank, the B-17 bomber, the Liberty ship, the proximity fuse. Less has been written about the systems that made those weapons useful, and almost nothing has been written about the plumbing. But plumbing, in the sense of reliable fluid handling, standardized connections, and predictable pressure management,
was woven through every aspect of American military logistics in ways that are invisible precisely because they worked.
The fuel pipeline system that the Army Corps of Engineers laid across France after the Normandy breakout in the summer of 1944, known as Pluto in the British Channel Crossing version, and as the American pipeline network inland, used standardized fittings throughout. The pumping stations were modular, assembled from components that any trained soldier from the Engineer Petroleum Distribution Company could install and maintain. When a section of pipe was damaged by German artillery, it was cut out and replaced with a standard section without fabrication. The fuel kept moving. The tanks kept rolling.
The hospital ships that took the wounded off the beaches used water systems built to Navy specifications that were interchangeable with the field hospital systems ashore. The landing craft maintenance ships in the harbors off Normandy and later in the Pacific used tools and fittings compatible with the boats they serviced. The Navy's Advanced Base Construction Battalions, the Seabees, built water systems in the Pacific Islands from components cataloged and standardized before the war, improvising constantly in conditions of heat and mud and enemy fire, but improvising around a framework of interchangeable parts that made improvisation effective rather than hopeless.
This was the system. It was not glamorous. It did not appear in newsreel footage. It did not produce heroes whose names appeared in the newspapers. What it produced was water, reliably, everywhere, in the quantities that armies of industrial modernity required. An American soldier in a foxhole in the Hurtgen Forest in November 1944, wet and freezing and under shell fire, was still drinking water that had been purified, piped, and delivered through a system whose components fit together the first time because they had been manufactured to the same standard. That is what the system gave him. He almost certainly did not know it. He had never known anything different.
The post-war revelation. When the war ended and American forces began the occupation of Germany and Japan, the infrastructure they found told them everything they needed to know about why they had won. German cities of any size had water systems, often impressively engineered by individual practitioners of great skill. But those systems, surveyed by American engineers in the summer of 1945, showed all the signatures of craftsman-dependent infrastructure. Pipe diameters varied in ways that reflected individual contractor preferences rather than rational system design. Fittings were sometimes custom machined to mate components that should have been standardized. Repair records, where they existed, were often the personal notebooks of individual tradesmen rather than formal documentation that anyone else could use. Japan presented the same picture in more acute form. Outside the major cities, Japanese water infrastructure was often a matter of individual wells and local arrangements. The parts were not interchangeable because the concept of interchangeable parts, in the American sense of mass-produced components manufactured to gauge-certified tolerances, had not fully penetrated Japanese civilian infrastructure by 1945. When American occupation authorities needed to restore water service to Japanese cities, they often found it easier to bring American equipment and American installation procedures than to attempt to work within the existing system. General Douglas MacArthur's occupation government made the rehabilitation of Japanese water and sanitation infrastructure one of its early priorities, both for public health reasons and for reasons that were quietly ideological. Clean water from a reliable municipal system was a daily demonstration of what industrial modernity, organized according to rational standards rather than individual craft traditions, could provide. Every morning that a Japanese citizen turned on a tap and water came out, they experienced a small lesson in the American system of manufacturing. The lesson was not lost. Japan's post-war industrial recovery, which became one of the economic miracles of the 20th century, was built on the wholesale adoption of the standardization principles that American engineers and business consultants brought with them in the late 1940s and 1950s. W. Edwards Deming, who went to Japan in 1950 to teach statistical quality control, was teaching the same gospel that Eli Whitney's successors had preached at Springfield and Harper's Ferry 130 years before. The part should fit every time, without adjustment.
What the tap meant. When Thomas Greaves' platoon moved into that Sicilian farmhouse in July of 1943, and Private Alderton pushed the flush handle and watched water fall cleanly into the bowl, he was not merely experiencing functional plumbing. He was experiencing the end product of a system that had been under construction in America for 100 years. He was experiencing John Hall's gauges at Harper's Ferry, encoded now in the thread specification of the water supply pipe. He was experiencing the Sellers thread standard of 1864, repeated 1,000 times in the joints behind the farmhouse wall. He was experiencing the insistence of 1,000 anonymous inspectors who had turned fittings and checked pressures and refused to sign off on installations that did not meet the specification, and whose refusals had forced the tradesmen to do it right, and whose collective refusals, multiplied over decades, had created a culture in which doing it right was not an aspiration, but an expectation.
The European soldiers who encountered American field sanitation systems during the war frequently used the same word to describe them: reliable. Not beautiful, not clever. Reliable. The pump worked. The connection held. The water was clean. The shower produced pressure you could feel. These were not engineering miracles. They were the ordinary output of a system that had decided a long time before the war that ordinary output was what it was in the business of producing, consistently, everywhere, by anyone trained to the standard. Germany's craftsmen were better as individual craftsmen. Germany's engineers were more brilliant as individual engineers. The Panther tank was more sophisticated than the Sherman on paper. The Type 21 submarine was more advanced than anything the Allies had built. None of it mattered, in the end, because sophistication without standardization is a monument to the man who built it, not a system that survives him. When the brilliant engineer was dead, or captured, or transferred, or simply unavailable at 3 in the morning when the pump failed, the system that depended on his specific knowledge failed with him. America had answered that problem differently. It had decided, by the middle of the 19th century, that the knowledge had to live in the standard, not in the man. The man was trained to the standard, served the standard, and was ultimately replaceable by another man trained to the same standard. This was not, as the German Facharbeiter understood, a compliment to individual craftsmen. It was an explicit rejection of the craftsman's irreplaceability as a design principle. The American system did not want irreplaceable craftsmen. It wanted interchangeable workers operating interchangeable systems, producing interchangeable parts. The system was everything. The man was a component. That is why Private Alderton could flush the toilet in Sicily. That is why the sergeant in the Hurtgen forest had clean water in his canteen. That is why the occupation forces in Japan could restore urban water service faster than Japanese engineers thought possible. That is, in the end, why the avalanche of American production that William Knutson described after the war was more than just a matter of numbers. The numbers were built on a foundation, and the foundation was a decision made long before any of them were born, in a federal armory in West Virginia, in a Philadelphia building committee hearing, in an engineer's office in Chicago. The system comes first. The part must fit. The tap must work. Every time, for everyone, without asking who installed it. America had been building that answer for 150 years. In the summer of 1943, on a beach in Sicily, a British private discovered what it felt like to live inside